Welcome to Lesson 3-1 on Scientific Notation. How do laws make things easier for us as a society? You may have said that laws give our society a set of rules to follow that allow us to behave in a fair, understandable, and consistent manner. Using these rules, society could be an easier place to coexist. In math, these laws are meant to shorten a process that add unnecessary steps when problem solving. In this lesson, we're going to introduce you to the laws of exponents, also called the power or indices. We'll get to indices pretty soon. An exponent of a number says how many times to use that number in multiplication. For example, 8 squared is equal to 8 times 8, which equals 64. So we could have 8 to the second power, or 8 to the power of 2, or simply 8 squared. So there's a lot of ways of looking at this as well. Here's some interesting laws that I found in my research. Take a moment to read them and give yourself a little laugh. In this lesson, we'll explore the product rule, quotient rule, power rule, negative exponents, and zero power rule. The product rule. This particular lesson, we looked at completing an investigation here. When multiplying terms with a common base, we add their exponents. So here we have base 3, 3 to the third times 3 to the fourth. In expanded form, which is up top, we see what it looks like. We could simplify each, get 27 times 81, and get 2187. Or we could use the product rule, which allows us to add together the two powers here, and then get 3 to the 7th power, and simplify to 2987. If the base is a number, then both these methods work well, but may become more challenging with smaller or larger bases, powers, variables, fractions, decimals, and so on. Take a moment to pause the video and try these practice problems. Okay, so we would have seen that our next step breaks them down here so that we have one base term and that we are adding together the powers. From there, we combine them and fully simplify. Make sure to be mindful of negative exponents. Negative 4 plus 7, negative 5 plus negative 3. The quotient rule, when dividing terms with a common base, we subtract their exponents. So the numerator, subtract or minus the denominator. Our numerator is on top in our fraction. So here's another example where we have expanded form and the quotient rule. And what you could imagine here is that these are all canceling out, canceling, and leaves us with a 1 on the bottom. So we have 5 over 1, and then we see that here with the quotient rule. Once again, if the base or exponents are numbers that are not easy to express in expanded form, the rule makes it easier to simplify. Try applying the rule to these examples. When we get to some of these later examples, like the green, 7 subtract negative 4. Well, you could think of it as 7 plus 4, but it's still using the quotient rule. Or negative 3 subtract negative 5. So you're working with these values. The power rule tells us to raise a power to a power. Just multiply the exponents. This you can think of as distributive property in some sorts. The expanded form would be challenging to calculate with larger powers. So here, well, 4 squared, that works, right? Because if I have 4 squared to the third power, that means 3 groups of 4 squares. So I have 1, 2, 3. Each one of those is 16. Here, I use distributive property. 3 times 2 becomes 6, 4 to the 6th power. Now, with numbers that are more challenging, we might want to use the calculator. For example, here in our first one, 6 to the 5th raised to the third power. Well, doing 6 to the 5th in your head would be challenging, and then actually raising that to a power of 3 would be even more challenging. So we use the power rule to distribute out, and what's important here is you see that anytime you have more than one part of a term, right, and this is a term because it's not connected, it's connected by multiplication, could be division also, and not addition or subtraction. So the power of 2 distributes both to the 7 and the 9 here. And here we have it fully simplified. And for simplicity's sake, right now we can leave a negative exponent. The zero power rule states that any base raised to the zero power equals 1. There's some philosophical debates on whether 0 to the 0 is 1. However, for our purposes, we're just going to hold this to be true. We see here that any individual number or variable to the 0 power is 1. But then we can also apply our rules. Negative 4 and 4 equal to 0 using the product rule, so x to the 0 is 1. Using the power rule, 0 times 5 is 0, so g to the 0 is 1. Using the quotient rule, 5 minus 5 is 0, so m to the 0 is 1. 0 power is 1. Negative exponents. This just means that the base is on the wrong side of the fraction line. So you need to flip the base to the other side. Once flipped, the exponent becomes negative. So deal with negative exponents. Sometimes the negative exponent is on the top of a fraction or implied over 1, and sometimes it is not. Here's a good example. 2 to the negative 3 really means 2 to the negative 3 over 1. So here we flip it. We can expand 2 to the third power as 2 times 2 times 2, and this becomes 1/8. So negative exponents make numbers, right, into fractions or decimals between 0 and 1, but they do not make the number negative. Simplify each expression, so no negative exponent is in the final answer. And you see this more common than not to fully take out that negative number. So the first step would be to flip it and then you can simplify the power. What's tricky here is that when you have a fraction, like 1/3, the fraction flips, and then the power becomes positive. So consistent here, and consistent even with variables. Then we use the power rule from there to fully simplify. Now that you've seen all the laws of exponents, let's show an example where we're going to use multiple laws of exponents in a progression. So I start with this expression by using the power rule. I distribute out the negative 2, the 3, and the 2 in the denominator. So as it simplifies here, I can go. And the nice thing about the laws of exponents is that the order in which you do these is up to you, as long as you're consistent. So here, I could actually work with these terms here. I could work with numerical terms here, but I'm going to follow just the progression I have already listed. After that, I simplify my negative exponent. 2 to the negative 2, well, that moves down to the denominator and makes that 2 to the positive 2. This can only be done if the exponent is negative. Here I had a to the negative 4 and a to the 15th, but I already simplified them with the product rule to get a to the 11th. Simplify my numerical values. 4 to the third, 2 squared times 3. Make sure 3 squared. Make sure you follow the order of operations here. You first simplify. So 4 times 9 is 36. And last, I'll use the quotient rule and then fully simplify. Check out this link if you want to see some cool video that a teacher made going over all of these rules. And just to revisit each rule here. So we have the product rule, the quotient rule, the power rule. Again, another version of the power rule. We see that m distributes to both parts of the term, and the power rule. See you next time.